Здравейте на всички. I actually suggest to make this lecture in English because we have some guests from abroad and we don't want them to be excluded. I hope that's fine with everyone here, right? Cool. Okay, so thank you for coming today. When Gennady told me that he's doing such an event, I actually got quite excited because I think this new technology that we have is very cool. I've been writing software literally for 30 years at this point. Started like in school and went through like algorithms, competition, stuff like that, and then commercial software. And I've seen like a lot of code. And what is happening right now is really exciting. I think this is literally the future. This is the more we progress, the less code we're gonna write, and this is amazing. It's much better for somebody else to actually write your code instead of doing it manually. And what I'm seeing with these tools is just a transition, like a huge leap forward. I don't hide that I literally don't write code anymore. I think it's actually more risky to allow people to write code. This is my personal experience, and it's just not worth the risk to leave code to people. You should leave the machines to write the code, and then the users, the developers, to be more of navigators, not so much the ones that are writing it. So today's talk we can split it into around like 5 sections. First I want to do like a little overview of how actually the tooling around software evolved during the years and how we ended up here. Then a little bit more kind of narrow overview of how the LLMs developed in the last, I would say, year and something. And then how the overall tooling is shaping and what is actually the tooling that I'm using right now. And I want to share like my findings, and I would be really curious to hear your thoughts and your experience in utilizing these tools, because I think if you really make a great agentic harness, like this is I guess the technical term at this point, this gives you an insane amount of leverage when it comes to achieving what you want to do. We're just starting, so yeah. So that would be around the structure of this talk, and yeah, let's start. So the whole idea of developer tooling is to make developers more productive. And it's always been, a huge part of the ecosystem, because we know the time of developers is expensive. And also, development of software takes a lot of time, which is kind of really limiting factor when it comes to building businesses. Because at the end of the day, you spend a lot of time and a lot of money in order to develop some system, and it's much better to get the results faster and cheaper. And I would say that in the whole history of software development, the demand for software services has been suppressed by the cost of software development, because you really need to budget your software cost very well, because otherwise, you might you run out of fund and you're out of business. So from that perspective, tooling has been really a lot of people were working on tooling. And if we want to do a kind of an overview how this tooling was developing, initially we had like a very simple autocomplete. The autocomplete was, I remember the days where even autocomplete was within the file that you're working with. Basically, all the words that are mentioned in the file, the IDE is gonna give you suggestions, and that basically increases the speed at which you output code, right? Then the things became more complicated, and we had stuff like language servers, which basically is a piece of software that takes your code base, processes it, builds an index of everything that is happening in it, and gives you more smart autocomplete suggestions. And that was amazing. I remember the days, when especially if you're writing like in Java or C++, you type dot and then all the methods of this class are listed, and that was, the most amazing thing. And then people were using different IDEs like IntelliJ or Visual Studio. Now we use Visual Studio Code, but before Visual Studio Code was this thing called Visual Studio, which was the most amazing IDE for C++ development, or IntelliJ or Eclipse, if you remember these days, when Eclipse was one of the most popular open source IDEs for Java. People were, raving about these tools. There were like a lot of plugins and stuff, and it all came down to, give you a suggestion. What will be the next thing that you want to write, so that you don't type it manually like the letters, but just to tap and autocomplete it. Before the LLMs happened, I actually also I had a friend that built a startup that was actually trying to use machine learning for autocomplete. And that was the first time that I kind of encountered this idea where the machine can introspect the code and it can figure out that, oh, here maybe you're trying to use the camera of the phone, and this is I know how the camera of the phone is used, so I'm gonna suggest you how exactly to use it, which is like one step forward from just the simple autocomplete. Because at this point it's not just listing you the function, it actually starts to figure out like what is your intent and give you like very smart suggestions what to do. And then the LLMs happened, which like completely shifted the paradigm, and the things kind of evolved from I would say let me see if I have this here. The first iteration of the LLMs was the simple chat box. So this is ChatGPT as we know it at the beginning, where you type in a question, you receive an answer, which is great because now you can ask the LLM to write you a whole program. You can tell it like, oh, write me a quick sort algorithm, for example. It's going to output something. But this is like a very one-to-one workflow. It's and also usually the agent can't verify its work. It's a little bit if you encounter this in university when you have an exam where you need to write code on a sheet of paper. For the LLM it's the same. You go to the exam and they tell you like, oh, write a quicksort algorithm, and for the LLM it's gonna remember how quicksort works. It can write it, but then it can't actually run the code and verify what it actually did. And we hated these exams because it's stupid. I mean, who writes code on a sheet of paper, right? So this initial iteration with the chat box, it's great, I would say, for brainstorming, for kind of replacement for Google or stuff like that. But for writing code, it's not really ideal. It's not like the best thing ever. So what happened after that, after the ChatGPT happened and people figured out, oh, this thing seems to be able to write code, was this thing called Copilot. And what Copilot did is to move the chat box closer to the source code, which is the IDE, where actually the source code happens. And then it started to become better at collecting the context in order to give you better results. And at that point, it became possible. At that point, it became possible to actually give the LLM tasks that are much more rich in context. So that would be, for example, I'm writing this functionality, write me tests for this class, for example, that I'm writing on. And here the context is, okay, here is the file, I'm seeing it, and the Copilot is also seeing this file, and then it's gonna start writing the tests. And that was, one step further. It was definitely better. And I remember when I first encountered that, I was like, oh, this actually has quite a lot of potential. But the big pain point was actually specifying an additional context, because in a lot of cases, in order to write this tests for this class, you also need to keep in mind something else that is, some additional files that you want to specify. And it was quite clunky back then because, you type in the chat box like write the test, and you also attach additional files that you want the AOM to take into consideration, and then it's going to provide a much more informed results. So that was great, but still it was something was missing. And looking back from now, it's obvious what was missing. That was the context collection. Like, how do you provide the context? And if you need to provide it manually, that's not working. And then came the agents, which is basically the AOM, but it's not now one-to-one interaction where you type a question or a task and then it produces the answer, maybe taking into account like a couple of contexts, but a multi-step process where the AOM is doing multiple steps, which can be distilled basically in this loop. I'm not sure that you'll be able to read it, but basically you collect the context, then you run the AOM. It's gonna make a plan how to solve the task. Then it's gonna use tools. It's gonna run some tools, and by tools we mean basically anything that it can help it. For example, calling CLI tools, calling some APIs, run the code and see what is the result from the tests and all that. Then it sees the results, it evaluates the results, figure out what are the next steps, and then decides whether it needs to continue or to do some additional work. And there is a very specific criteria when the loop is gonna end. It has like the success criteria, and when the AOM decides that, okay, I'm finished now, the task is finished, then it's gonna stop working and produce the result. This multi-step process is very powerful because now you can abstract pretty much any task with this way. The AOM is gonna plan how to do the task, it's gonna run the tools, it's gonna evaluate the results and come back. Now, the whole idea becomes, how do I empower the AOM the most? And by empowering is what tools I'm gonna give it. So the more tools the AOM has at its disposal, the more powerful that AOM is gonna be. And this is where the huge leverage comes in. This is where it's very important to allow the AOM to use all the possible tools. And the comparison with with a human will be, on one hand, you have the student in the university writing a program on a sheet of paper. Then you have the developer that has Stack Overflow, has the ID, is able to compile the code, to run tests, to do formal verification of the code and all that. It's pretty much the same. That was, I think, the big paradigm. This is, I think, this system with the agent loops happened, I believe, around middle of last year was when this paradigm happened. And this is the time I think I kind of discovered the whole thing maybe around October, November, and I was totally blown away. And from there, I'm constantly interested like how to make this thing better and better. And I think at that point it was pretty clear that humans are not going to write code anymore. That it's just not worth it. And if we have to distill it into two things, what the agent loop allowed is, first, the agents can collect the context automatically. No, I don't need to specify manually, these are the files you need to read. The agent is going to figure this out by its own. And then the arbitrary to use, so the agent is able to use whatever you give it to him. And the most important part is that he's able to figure out how to use it. So you don't need to write some custom code to describe it. It's enough to have a text documentation saying like, here is a tool that you can achieve this and that, and here is how you use it. And when you give that to the agent is going to be able to use it. So these two things kind of empower the whole thing. So now the question is how to use these tools. And narrowing down at the evolution at the LLM level, if we need to distill it, it's ChatGPT, the one-to-one question answer. Then we start to move the chat box closer to the code. Then we get the code and codex systems, which are like the agentic systems for writing the code and doing the stuff. And the final step is OpenClaw Hermes, which are the open source versions of codex, basically. But why they are important, in my opinion, is because the community now, it's much more powerful than OpenAI or Anthropic write these tools, and they give you a lot of opportunities to extend these systems and plug different stuff into them. They're like very open ecosystem driven projects. Particularly, I use Hermes at this point. I started with OpenClaw, now use Hermes. I think it's developed much better. And I like the batteries included mentality that the team is having. Here you can also throw, for example, Pi, which is a very bare bone agentic harness. But in my opinion, I'm more of a Rails guy. I used to write a lot of Ruby on Rails, and I like the batteries included mentality where you have everything that you need from the very beginning. You don't need to set up a lot of things. So this is good. We managed to achieve a lot. We managed to develop a lot. But I think we can do better. And this is we are now coming to the real interesting part, because you probably already know all of this stuff that I told you. One of the limitations of working with an agent loop is that usually you work on one task at a time. Now, you probably saw people bragging how they have like a huge monitor with 20 codex sessions open at the same time, and the terminals are scrolling left and right, and they work on like 20 things at the same time and all that. But I think that's not very optimal. In my opinion, just the front end to achieve that, just using multiple codex sessions, is not optimal. And here we are going towards, now the question is, how do we change the dev tooling, the interaction with the system, so that it's very efficient and we are able to do our work the best. And in my opinion, having 20 terminal windows open and stuff happening on them is not really the most optimal way to work with this. And the other part that I think is also not so discussed on social is the team setting. How do we utilize the systems when we work in a team with people and we want to allow them to collaborate on these things? So my answer to both of these questions at the moment is to use a Kanban board. So probably most of you are familiar with what a Kanban board is. It's basically what we use in the Scrum methodology of developing software, which is basically a board with cards. It's like a notes on the wall where we write different tasks. We describe the tasks, and the tasks are moving from to do to finished. So tasks are first go in the backlog, then they go to do, then they go to in progress, in review, and finally done. Usually these are the main stages where the tasks are going. So with a Kanban board, we are able to have multiple tasks happening at the same time, because each card we describe what exactly we want to achieve. And also we have the context of the tasks kind of very well defined in the card. And visually we are able to see what exactly is happening. Now, the way this works is, I'm going to show you a demo later. Actually, let me open see whether I can find, yeah, here is basically the demo. I'm using a system called Multica. There are many of them actually that are available. There is also Paperclip, is very popular one. Hermes is coming with a Kanban board built into the agent. I found this multi-cut to be the balance between simplicity and functionality. But basically, you describe the boards here. I can write a task. I can actually, the most important, the most amazing thing is I can write the task using an agent. So I press C, and the whole idea is that I defined different agents in the. Okay. Yeah, sure. Let's see if. Okay, it's better now, right? Yeah. Okay, good. So you define the agents as a very simple description where you say like you're a senior software engineer that writes front-end, back-end code. When you're working with Python, you're gonna use these tools. When you're working with front-end, you're gonna use that. You're gonna use test-driven development and stuff like that. So you describe basically what the agent should be doing, and then you can give the agent tasks. And here, you know, it's very convenient because you say like, for example, I built like a very simple workout tracker for biking, because I went to bike in Vituša and I wanted to visualize my tracking with some statistics. And I can tell the agent, because he should be familiar actually with this project because we already worked with it and he has some memory. I can tell him like, take the e-bike tracker that we built a few days ago and implement darkened light theme for the front end with a button to switch between them. And I submit the task, and then the agent in the background is gonna create the task on the board and start working on it.
How does it know that you built an app 2 days ago?
It has memory. So memory is part of the. This is something that I haven't really touched in this presentation, but basically these agents like Hermes, for example, they allow to have a memory system attached to them. They come with a very simple memory that is based on markdown files. When they work on something, they write in a file that, oh, like I worked on this. I actually connect a whole memory system that is using APIs to collect all this information. But and here is the task, and then the agent is gonna start working on it. Like hacker, this is the name of the agent, is working on this thing. So now I can create like other tasks. Yeah, here he moved it in progress. He's gonna continue working on that while we speak. And I can create like a bunch of these tasks for the agents to work on. Now, something that I haven't mentioned is that, you know, a lot of people believe that they're gonna be giving tasks to these agents in order, like very high level, in the sort of build me a 1 million ARR business and don't make mistakes. But I think this is not realistic. Human needs to be in the loop in order to verify that what we are actually doing is the right thing to do, because we have ideas of what we want to do, right? But we have it in our head and we can't translate what is our head here. And there is like a gazillion ways that a given thing can be achieved. The AI can't read our mind yet. And something that I actually figured out that is very effective when work with these agents, especially the early stage of a project, is to tell them literally grill me with questions about what we want to build here. And grill me is as an important verb because it kind of implies that they need to really ask you like as much questions as possible. And they're gonna come back with like 50 questions about stuff that you've never thought about. And then you're gonna spend a lot of time answering these questions, and they're gonna give you a much better definition of what exactly you want to achieve here. So So let's continue. Now the beautiful thing about the Kanban board is it's not now as opposed to like a bunch of terminals on your screen. You can use this in a team environment because this thing here, you give access to this to all your team, and now everyone collaborates on these things together. They can submit tasks, they can see what everyone is working on, and you can send links to people, like open a card, send it to somebody on your team, say, yeah, check what we built here, give some feedback, that. So that's very, very useful. Okay, so when we go at the team setting, and I'm gonna try to actually make this bigger.
Before we continue, I think we have a question.
Yeah, sure.
What happened with the code review stage?
Yeah, we're gonna see that. Basically, code review is part of the whole system. Like, I actually hope the demo is gonna work, and this agent, so what I'm expecting now from this agent to do while we are talking here is to write the functionality, open a pull request on GitHub, run the test, make sure that it all passes green, then make screenshots and attach them to the card, so that when I open it, I can both see what the agent actually produced and have a link to the PR to open it and review the code.
Where is all of this running, and how much does it actually cost?
So this particular thing is running on a machine at home. I'm connecting through Tailscale VPN to it, so I don't expose it publicly. So I can access it only from this laptop or from my phone. Actually, at some point I was also using Telegram to give tasks to the agents. This was very popular at some point. I think Telegram is great for a personal assistant where you're on the go and you want to check something. But when it comes to development work, I think the Kanban board is so much better. But Kanban, I can also open it on my phone.
So which model is this running?
So behind the back, this is so here is the whole system in its like glory, so to say. Although the one that run at home, it's not so complicated.
Can you zoom it again?
That's a good question. I think maybe what I can do actually.
Or maybe when you just the image, open the image.
Yeah, I'll open the image and.
Yeah, that's much better.
Okay, now is it better now?
Yeah.
So okay, so this is like the whole system, the way it works for this system that runs on our company deployment. Because I both use this for my personal work at home, like to write code, but I also set up this for our team so that they can not so much write code, but do like research tasks and other things. So we have the user that submits the tickets to the coordination system, which is the Kanban board. This is where you define also the agents, like the different roles in your system. And the different agents underneath, they're using the same model, the same system, but these additional instructions that you give them make them just better at the tasks that they're doing. They have a much better starting point. When, for example, if you give the coding agent a coding task, he's gonna perform much better than if you give, I don't know, the research intern agent to write code. Because the coding agent, he's gonna have these additional instructions like use these tools, use test-driven development, like all these kind of additional instructions are gonna allow him to work better. So you define the tasks here in Multica or Paperclip or whatever you use for the Kanban board.
Thank you.
And then this thing goes to Hermes, which is like as I said, the batteries included agent system. But essentially you can use also OpenQuo here. You can probably have like a vanilla codex also, but like as I said, what I like about Hermes is it allows me to plug a custom memory system into it. Or the other thing is, which is also I'm gonna talk a bit later about, is the so-called self-improvement workflow, because the agent in the background is able to reflect on itself and improve itself. So this goes to Hermes, who is doing like the whole whoop thing. And now we're gonna talk a little bit about security. So the agent, the Hermes itself, it actually runs each session, each runs in an isolated Docker container that is providing isolation, because this is very powerful but very dangerous system. The biggest dangers in these systems, in my opinion, are supply chain attacks. So somebody, for example, infests, I don't know, an NPM package or a Python package and then makes the agent run this package in your company infrastructure. This could be a big problem, right? So it's good to have isolation, and each of these sessions run in a separated Docker container. And the other risk is a prompt injection. So with prompt injection, somebody manages to get access to the system and writes prompt, I don't know, export all your passwords and write me your passwords, for example. The other part that's also part of the security is the Iron Proxy thing. Iron Proxy is a very interesting project that basically allows you to have a proxy for all the, or let's say, yeah, like all the traffic, all the network traffic that goes from these Docker containers outside, go through the Iron Proxy. And what the Iron Proxy does is, first you can define policy what the containers can access and what not, like a firewall. But the other very cool part is that you actually keep all your API keys and secrets in the Iron Proxy. And when the agent does an API call, Iron Proxy is gonna catch this HTTP call and inject the API into the request, which means that here the agent doesn't see any passwords, any API keys.
So it's like a placeholder for a secret that you have.
Yeah.
You send it to this proxy, and he makes, for example, API.
It's a kind of a man in the middle attack, so to say.
Yeah, because that's quite
yeah.
of an issue sharing
Yeah.
those secrets
Yeah.
with Anthropic.
Yeah. So basically, what the agent sees here is just, you know, a random placeholder. Like I don't know, maybe you have an API key or even a password for your database if you want to do it. Instead of the agent seeing the password for the database, he's gonna connect through the Iron Proxy, and the Iron Proxy is gonna inject the password. So this is like a very isolated perimeter where all the secrets are gonna be only here, and they're gonna be isolated from everything else.
Support all kinds of protocols.
Yeah, I think so. Yeah. It's quite powerful. Yeah. So I mean, actually, to be honest, in some cases, you might need to implement an additional broker for some of the connections. So it might not. You're right. It's in some cases you won't be able to use the Iron Proxy, but once you start building the system in this way, it becomes part of the runbook. Like if I want to give these agents additional tools, additional access to some internal system or some paid service or something like that, I'm gonna make sure that it goes through the Iron Proxy, or maybe build like a separate broker for this thing. But I think it's important to have this kind of distinction where here what runs in these Docker containers needs to be isolated, and it needs to have zero access to any passwords and secrets in order to prevent leaking these things. And you know, then the request goes to all these private systems. And the beauty of the whole thing is that when you give access to your agents to all this, you know, additional stuff that they can use, this becomes like very powerful. Like for example, in our company system, I also provided like a design system and instructions how to the agent to write reports, and a special place where they can upload the reports and share links to these reports, so that now when I want, for example, to build a report for, I don't know, researching something, it's going to generate a shareable link that I can take and send it to a coworker or to some contragent, like some other company that I work with. And so far, like the impression was like when I sent this report to like another company, they're like blown away, like because usually you generate the report in like 30 minutes. Because this is how much the agent takes in order to do the research and compile the report, and then you send it to them, and like the turnaround time is just crazy. And it's all branded with your company design and everything. It has access to all sorts of things that humans have, and it does its job better than humans, basically. So this is basically the system that I wanted to kind of share, which is how I imagine right now for this thing to work in a company system. And maybe before we come back to the board and see what the agent actually produced, I'll be very curious to see a few words about the self-improvement. Actually, let's see if we need. Oh, it's done. Oh yeah, here we have a pull request. We have a pull request we can open at the repository. Here it's submitted by me. Here is some CSS and stuff like that. It's it has a pull request, and you can see it also created a screenshot of how the system is gonna look. Now I don't see where, to be honest, the button is for changing it. Let's see. A persistent theme. Here. Yeah. It's at the top. Yeah. Here, light theme and dark theme, so you can switch it. This kind of shows you how powerful this thing is. And here, actually, it's not so complicated. I mean, this whole thing, it has just access to GitHub, so that's basically the external system it has, and some additional instructions to generate the screenshots and stuff. Yeah, Jane.
How does the agent know that you expect screenshots linked to PR? Do you have a separate reviewer agent?
So that's an interesting one. So either you tell it in the instructions of the agents here when you define the agents. So here, when working on front-end tasks, make sure to post a screenshot of the relevant pages so that the operator can quickly review the changes and request adjustments. And then there is the final instruction. You are always careful not to leak secrets to the outside world, for example, by committing them into Git. So this type of additional instructions help a lot. The test-driven development is also very useful because that allows the agent also to work in a more efficient way to write better tests. So, I mean, when you start working with these agents, you start to learn this kind of little shortcuts. When you notice, for example, that the agent is consistently not doing something important, you write it here in the instructions. Okay, and a few words about the self-improvement workflow, because I think this is like really mind-blowing. I saw it in Hermes when I started working on Hermes.
Didn't you say that it was either or, so this was one of the options to put it as an instruction, and the other option is what?
The other option is to rely on the memory of the agent. So what happens usually with this system, what is it?
So to put it in agents and...
No. So these agents, they, as I mentioned, they have memory. They remember what happened in the past. And when you give them tasks, they try to find in their memory relevant entries out of their memory that are related to the task that you gave them. For example, here I told the agent, let's work on our bike tracking application, right? I didn't specify the URL or anything. For this part, I relied on the memory of the agents that it remembers that we worked a week ago on this thing. And then when I mentioned like, oh, let's work on the bike tracking app, it's gonna look up at the memory bank and it's gonna find, I worked on this and here is the repository. So you can rely on this, but I would say that memory is a bit less reliable compared to having the instructions. Like with the instructions, you're sure that they always gonna see that. With memory, they might not find that relevant piece or something that is very important. So I would say that when you really want something for the agent to always have in mind when it works, you put it in the instructions. When you just rely on the agents to be smart and figure out, from past experiences that maybe you worked on something or you did something, then you rely on memory. But these are the two kind of magical things that, it starts to look like a real human, right? On the self-improvement thing, this is something that I first saw on Hermes when I started using it. And the idea is actually very simple. So what Hermes does and what this system does is that on a recurring basis, it's going to look at all the sessions that it did, let's say in the last 24 hours, analyze these sessions and extract skills out of them to be reused in the future. Now, why is that great? And not only extract skills, but also refine the skills that it already has. Now, why is that really awesome? It's awesome because when these agents work on stuff, in many cases, they need to invent an algorithm in order to achieve their work. They're going to try different things and they're going to figure out, in order to, do on-chain analysis, I need to connect to this Etherscan service and I'm going to use the Etherscan service in this way. These are the API calls. And then it's going to take some time for the agent to figure out what are all the steps. But when the agent does this retrospection on the sessions, it's going to see here is something that I kind of struggled with doing. Let me extract an algorithm for on-chain analysis. And in this algorithm, it's going to be written use this tool in this way, and this is the algorithm. So next time that the agent needs to do the same task, instead of struggling and inventing the wheel over and over again, it's going to just use the ready algorithm. This is going to save you time and going to save you tokens. This is the whole the whole idea of the whole thing. And here in this system, actually, I made it so that it opens pull requests with the skills that it managed to extract. And it's very interesting, in the morning to open the pull requests and see what are the latest thing that my agent learned how to do. And you can review them and see he figured out how to do this, and then you just approve it and merge it. So that's a very nice touch. So as a closing thing, I think the whole takeaway is I believe we are at the stage where these agents, we need to figure out how is the best way to work with them so that we get the maximum amount of leverage. And I think there is a lot of work to be done there. When it comes to collaboration with people, when it comes to how to work with tools, even for security, because this picture that I show you kind of combines all these things into the same thing. And I think we have a lot of work when it comes to having customized UIs and customized workflows to work with these agents. What really opened my eyes was Quad Design. Quad Design is a customized app for using these agents to create designs. And it's customized in a way that makes designers very, very efficient. And I give you an example how they're very efficient. Imagine you need to do a mobile app, a design for a mobile app. You tell the Quad Design, you can look up some tutorials on YouTube. It's crazy. You tell it give me 3 different versions for design of this app, and it's going to produce 3 different versions. And then each version is going to have buttons to tweak the design, maybe change the font or change the layout a little bit. And then you tell it, but I don't want to have just 3 buttons to change stuff. I want to have 50 buttons to change different things. And suddenly, this tool allows you to explore so many branches in the design that no human designer is going to create 50 different variations and allow you to switch between them. It's just too time consuming. There is no way he can do it. The agent can do this, and then the human can explore all these different options and settle for a design that ultimately is going to be better than any human is able to produce. So having this customized UI could open a lot of possibilities and make you like the amount of leverage that you get is insane. And I'm gonna close the talk with giving an example of something that I saw created by GitHub Next. GitHub Next is a department of GitHub of they saw like fuck around and find out. So basically research and development. So they just figure out crazy ideas, they work on them, and they create proof of concepts. And then maybe the proof of concept is adopted, maybe not, but you know, they're not paid for creating like a direct business value, but just to explore different crazy ideas. There is a talk about a project, it's called ACE. I link here, probably Gennady is going to share the slides after that, you can watch the video. But this is an idea of how a customized collaboration environment for humans, for apps could look like. They built a proof of concept of that. It's very similar to Slack. So the structure is the following. Here you have all the sessions. You can imagine these are all the features that the team is working on, and these are like different channels. So each feature is going to be a different channel, and in the channel you invite all the team members that are going to be involved in developing this feature. Here in the middle you can write messages between the people, you can discuss stuff, or you can tell the agent to do work, to do some changes to the app. And here on the right, you have a cloud environment where the app you are developing is running. This is the branch on which the agent is working right now. And in real time, you see the changes that the agent is doing to the app as you are talking with the people, discussing the features and giving instructions to the agent. So each feature is going to create automatically this cloud environment where things are going to be running. And here the collaboration between the people is happening. And the whole idea, the lady in the lecture is explaining it very well. The paradigm changed where now the development of software, like the development of product, used to be a huge chunk of time is building the software. Now the chunk is very, very small. So the problem now becomes being on the same page of what we are building and how this thing needs to function and how to look like. So this collaboration part, like this big part here, is the most important part where all the team members involved are going to be discussing this feature, giving feedback, making decisions and all that, and the agent is just working in the background and implementing everything. So I'm really excited about the future, and we'll see where it leads us. So if you have any questions, let me know and we can discuss. So thank you. Yeah.
I was wondering when, for example, 2 or 3 agents are working on the same thing, the same project, how do they and they clash? For example, there is maybe a merge conflict between them. How did they do resolve this? Does it like the first one that's kind of submits the change? How do they have a context of the changes that are done by the others? Or do you like orchestrate it in a way that they don't clash?
So I can tell you how my workflow works. Like this board is pretty empty because this is just for some personal projects. But when I work on company stuff, there's gonna be like a gazillion of cards here. And how the workflow works is that I'm gonna create like a bunch of cards, and usually I max out around 3 or 4 tasks at the same time, because by the time you review, you give the agent tasks, by the time you're finished with the last task, the first one is gonna be ready with something to be done. So what happens is that in this inbox here, I'm gonna receive the notifications about as the tasks are becoming available, and my role is gonna be, I'm gonna look at the what is happening. I'm gonna give additional instructions, or I gonna do pull request review. When the things are ready, I'm gonna merge the pull request. And now this could potentially open the possibility that other tasks have merge conflicts, right? Now, when I proceed, I'm gonna mark this as done, and then I'm gonna proceed to the next task, right? I'm gonna see there is a merge conflict. If I really think that I'm very close to merging it, I'm just gonna say the agent resolve the merge conflicts, and then I'm gonna continue looking at the thing. And if I think that maybe something that I merged previously is connected with this, I'm gonna tell the agent, oh, I merged something, like take a look of what I merged and figure out if something needs to happen. And it's not a problem, like, because merge conflicts is just like a boring work that the agent can do very easy. What is harder to actually orchestrate is, imagine you want to build like a bigger feature that's gonna involve a couple of different tasks. So in that case, usually I start with a planning phase where, agent's gonna grill me with questions and all that. And then after we define the task, I'm gonna tell it like, oh, now create, for each step of this plan, create task here, like a ticket, but make sure that the dependency of the tasks is such that you don't start working on something before all the prerequisites are done, right? What I notice here, because it rarely happens to me, so I haven't really dived deep, but what I notice is that the agent is smart enough to have like an epic card where all the subtasks are defined. And as the initial tasks are done, it's going to come back to the epic and figure out, okay, now there are like additional things that I need to start working on because previous things are already, the prerequisites are ready. In that case, you just need to be careful not to start working on something before the prerequisites are done. So that with this Mutica thing,
Like with real people, basically.
yeah. With real people is similar, but yeah, it's not like a huge issue. Like I would say it's not like a huge problem. Mm-hmm.
Can you say something about what LLMs you're using?
I'm using mostly codecs, to be honest. I think at this point LLMs are smart enough to be able to, like, whatever you use for the, like, either OpenAI or Claude, I don't think there's gonna be a huge difference.
You tried running with local LLMs?
I tried. I have a 3090 at home, a GPU, but it's not enough.
You need more.
It's not enough. You need more. Yeah, you need to have a cluster with, I don't know, few hundred gigabytes of memory, which is like very expensive at this point. I don't think it's really worth it. It costs like a ton of money. What I tried at some point was to have a smart agent to define the tasks, and then a dumb agent, like for example Grok is a very fast and dumb agent, but he produces code like crazy. Like he's able to Grok generates code like 10 times faster than Codex. It's insane. But to be honest, I haven't reached to a use case where that would be like a big thing. I do like a hackish approach where for all this I use my monthly subscription, which is like $100 per month, and it's enough for me. I really can't max it out at this point. Maybe 70% of it, even with like parallel tasks.
My experience with OpenClaw was that the turns would sometimes start consuming tokens extremely fast.
I think I managed to use so far. Like I usually use around in good days maybe 100 million tokens per day. I managed in 1 month. I think my record in 1 month was 1.5 billion tokens for a whole month, and it was within the limit of $100 subscription. So I think right now subscriptions are heavily subsidized, at least 10x. So if you are using all this on a per token basis, it's gonna cost you $2,000 per month. With a subscription, it's just $100 and it's great. But for a company setting, yeah, it's problematic. I think this is the biggest roadblock right now for businesses adopting these LLMs, basically the cost, because you need to budget it. You can't be sure if some developer won't go crazy and burn a lot of tokens. So you need to have this in mind. And the other is like the security part. You need to really pay attention to this. Yeah.
So when you use this for coding, how complicated are the code bases where you are using it?
Good question. I mean, let me tell you a story of what happened initially when I found this thing. I was like, okay, now AI is gonna write our code, and I'm just gonna sit back and I'm gonna, be a real product owner and just start pounding features. Like, this is what I want, and I don't care about the code at all, right? And at that time, I was building some trading system that had to trade like real money on real exchanges. And at some point, what happened is like, obviously, the system had bugs. And when the bug happened, I tell the agent, like, here is a bug, fix it. And the agent at some point reached to a point where it was not able to fix it. It thinks that it manages to fix the bug, but it actually didn't fix the bug. So at that point, I figured out that this is like the tipping point where it produced such a mud ball of spaghetti that it can't really figure it out. And what I did at that point was, I said like, okay, so we need to refactor this code base because it's like a lot of spaghetti. Here is like our use cases. We already defined them. So now let's figure out like an architecture, how to do it. And the agent managed to figure out a very good architecture actually. So we went through a cycle of like refactoring, and then everything started to work much better. So that basically the tipping point was when the agent can't fix the bugs, can't find basically one shot the problem. This is where you know that you reach to a point where something is wrong with the code. You need to take a step back and fix it. And I think the really important part is to make the code in isolated modules so that each functionality is very kind of isolated. And when the agent works on something, he's able to figure out, okay, this is the context, like carve out exactly the subset of context from the project that it needs to work on, and be able, and this to be a manageable piece of code to work. If it's a very entangled spaghetti code, then everything is connected with everything, and the agent is not going to be able to figure it out. So I think this is why it's important to have the human in the loop to do the reviews, because my code reviews right now are, I'm not looking at every line of code, like for sure. What I'm trying to identify is code smells. Like, for example, big files with a lot of code, like thousands of lines. When I see a big file with a lot of code, this means that, oh, we probably have a lot of mixed functionality here in this file. And I'm going to tell the agent, like, this file is so big, like, can we do something in order to reduce it? And then usually the agent is going to come back to me and say, oh yeah, you're right. There is like a couple of responsibilities in this file that are mixed together. So we can separate this into different things. This is basically my code reviews at this point, like identifying big functions, big files, logic that is very nested with a lot of conditions, stuff like that. And when I identify such code smell, I try to eliminate it as quickly as possible.
So a follow-up question, in your company, how many people are writing code? And how
It's
do you
me.
collaborate? It's just
Yeah, it's only me. Yeah. No, actually 2 people. No, we have a front-end people. We have a front-end guy now. Yeah. But I think I actually don't miss having people. Yeah.
I guess my question is in some way similar. You mentioned the Kanban as a way to leverage bigger productivity, but doesn't it happen that your input is actively needed for the agent to be able to move the task forward?
Yeah.
Because if that's the case, why is it so much better than just working independently?
Because when you work on a couple of tasks, the Kanban board allows you to be able to switch between different contexts very, very efficiently and to see the history of this feature. So in some case, I'm gonna have a very long conversation. It's almost like having different chat sessions with the agent. Like each card is a different chat session here, where I'm gonna be, like for example, you can see this is basically the card for building this thing, and it's actually very long. Like I had a lot of back and forth with the agent until we actually reached to the state that I wanted the things to be. We discussed a lot of things, and when you have this in one place, then you are sure that when you discuss all these things back and forth, it's going to take into account this particular context and not like something else. So I think with the Kanban board, this kind of isolate, like keeping all the context in one place is valuable. And also I know that this thing is going to survive restarts, right? Like if I close my terminal, I'm going to lose the history of, let's say, this feature, while here I have it kind of in a system that keeps it.
So I guess that's more or less equivalent to what you have with code. If you go to like your previous chat sessions, but what you're having here is better structured.
If you use code like the desktop app, I think it's very similar because you have like different sessions for every feature, right?
Well, I mean the CLI tool. If you go to code resume, it gives you this long history of previous.
Yeah.
And it seems maybe very similar to what you have here, but yeah, I can see how this is much more readable. And
if you see just the list of sessions, you are not quite sure which is a task that you're already done. Like for example, what happened to me is if I work on 3 different things, I'm like, okay, which session was this thing that I was working, because it's mixed with all these other things. And here I can identify it because the moment when I'm happy with the feature, I'm gonna just move the card to done, and then it's over. I don't see it anymore, and I know how to concentrate. And it's actually, there is another thing that I did with this system. Every morning it goes through the production logs of the system and gives me an operational report of what's going on. So when I sit, I have like a card created, which I open and say like, oh, like maybe there is some new errors, or maybe the disk space is full or something like that. It just runs in the morning and gives me a summary of whether all the systems are operational. If there is maybe some problem somewhere, maybe an authentication stopped working or something like that. So you can also do like tasks like that, like a recurring tasks.
I guess the underlying implementation is most probably similar. If you have like a long ticket, this back and forth discussion you showed, most probably it's similar to like it's sending the text to the LM.
Yeah, pretty much. Yes. It sends all the context and then the LM. I mean, here in the picture that I shared, the Docker containers are literally short-lived. So it's gonna spawn a new Docker container for every question that you write. So you write a question, it's gonna create a Docker container, and then when it's finished, the Docker container is removed. Which actually introduces some latency in the system, unfortunately. Like one question and answer usually takes 30 to 40 seconds, which is...
This is because of you talk to the LLM, not...
No, because of the Docker... This is the latency for the Docker container to spawn and everything. So that's...
Is this a big enough problem that you want to solve?
At the moment, no, because usually the tasks that I give the AOM are gonna take minutes to finish. So it's very different from chatting with the agent. For chatting, there is actually a separate chat here that you can discuss stuff. But yeah, this is different from chatting with the agents. It's more like giving tasks and defining tickets. Mm-hmm.
I'm sorry if I missed the point. You mentioned that you're using some normal subscription for Codex, but is this tool subscribed? And how does it work in reality? All of the framework of tools that you're using, I guess, yeah, Docker, I guess it can be open free and so on, but some of them, I guess, are subscriptions or payments. How does it happen?
Everything is open source. Here, yes, everything is run on-premise, yeah, on a virtual server in DigitalOcean, yeah, everything.
That's surprising. I thought it it's a tool.
Can you write a
It
book
must
on
be
how you did it?
What is it?
Do you have a book where you write how you do the whole thing?
No, not really, but
It's
yeah,
intended.
it's actually all defined as infrastructure in code, as code, infrastructure as code, and all the services. Basically, everything runs in Docker containers. All the services, everything. This Multica is an open source project. Hermes is open source. Yeah, like Docker, Iron Proxy is open source. Everything. I actually even experimented with running like an open source version of Quad Design on this machine, basically to allow designers to be able, like they literally utilize the same Hermes agent but for design work. And this is actually presentation was done by a project called Open Design that replicates Quad Design, but in an open source setting, and you just tell the AOM like deploy me Open Design in Docker, whatever, it's gonna figure it out. Yeah.
I was wondering if you were able to get the trading application that you talked about working.
Yeah. It's been very good. I mean, it's not making money at the moment because this particular arbitrage it doesn't exist anymore. But yeah, it was able to really build a system very well designed where each bug that I had, it was able to debug it. Literally, I was just throwing it log files, like hundreds of megabytes of compressed log files. It's able to grab to the files, find what exactly is wrong, and fix it.
It was trading stocks.
It was trading crypto assets. Yeah, it was arbitraging funding rates on perpetual futures, because there was like a dislocation between the funding rates of different venues. So it was possible to open delta neutral positions, and yeah, I mean it was it traded quite a lot of volume. But yeah, the part with taking a step back and defining the architecture, I think it's very important. And the agent was able to do like a very nice event-driven system. Each piece of code is like an isolated class that is able to be tested in isolation very well. Then it was generating like an event log of everything that it did, and it was very easy to debug these problems looking at the event logs. It was able to find, because you trade between like two different exchanges and you receive notifications, you monitor the order books. It was not trivial at all, and yeah, it worked pretty well. But on the second try, as I said, like the first try, being just a product owner, it doesn't work. You still need to be the right navigator and give directions. Mm-hmm.
Do you have experience about the optimal number of instructions to provide the agent? Because, for example, when you talk about spaghetti code, to think about the architecture, actually you can add this into the instruction, like please think about architecture and do not provide spaghetti code. So I was thinking about every time you have a learning based on the interaction with the agent, you can write your learning into as a new instruction. And then I was also thinking about, could there be too many instructions, or is there an optimal point?
So all these agents, they have this thing called context window, which is basically all the information that they can fit in their head when they're doing some work. Right now, the state-of-the-art models, they have like 1 million tokens of context, which roughly speaking is like 1 million words, let's say, that they can fit, which sounds a lot. Now, the problem is what people are saying, that if you fill 50% of this context window, suddenly the agent is going to become more and more dumb. So you really need to be careful not to overfill the context of the agent. And the moment when you reach this 500,000 tokens, you need to do the so-called compaction, which is basically you tell the agent make a summary of all this context and make it shorter. So it's gonna kind of compress it. So from that perspective, if you go overboard with instructions, with a lot of text, that's gonna be counterproductive usually. I think agents are able to work very well with relatively short amount of instructions. I try to give, really like to keep this instructions file very, very small, maybe like one page. I don't think you really need something like 10 pages of instructions. As you work with it, I think you discover what are the important things to tell it. For example, the test-driven development seems to be a very good instruction to give. Because just the way the agents usually work, they try to one-shot things quite a lot, which is not ideal usually. With test-driven development, they start working on like smaller chunks. The other thing is the grill me thing is very nice to ask you more questions. As for architecture and stuff, I think there is a lot of value in putting linters and type checks and automated tools to be checking your code. I experimented a little bit with complexity analysis. So you can run a tool that for each pull request is going to analyze the code and identify whether the complexity of the code is not crazy, like maybe you have a lot of conditions, or maybe you have very long files or stuff like that. You can put these rules as hard rules for your code. So the agent is not going to be able to create code that is against these rules. So a lot of people say that there is like a lot of value into that. I personally haven't put enough mileage on this to share experience, but I think it will be valuable to have. Like for example, one friend was joking that he put so many static analysis and tools that he as a human can't write any code in this code base. It's like so complicated to be able to fulfill all these requirements that it's impossible, but the agent is able to figure it out. But I think this is, I mean, humans are not gonna be completely out of the game. I think humans will be very important because humans are able to really think on a much, much higher level. We're able to fit a lot of context in our head that I think is superior compared to the agents, and I believe we are very important navigators in the work of agents, but they can make us, I think, 10x more productive, literally.
Okay, folks, so if you don't have any more questions, or if you have more
I have a
questions.
final philosophical question. Like,
Yeah.
where do you find any joy doing any of this? Because I think for most of us, we became like software engineers because we enjoyed solving problems, and now we're turning into glorified code reviewers. For you personally, do you like this? Like,
I can tell you that the joy returned to me after the agents appeared, because after all these years writing code, and I mean, I remember when I was a kid, you know, make the computer do what you want was the most amazing thing ever. I think we just transitioned to a much higher level. It kind of returned the joy to me to make the computer do stuff, because I think I was just tired of how much time writing software takes, right? Here, software suddenly it's so fast to achieve. So now you can achieve your goals so much faster. You can do so much more stuff in a short period of time. So I think it's very exciting to me personally.
Okay, so on that note, let's thank Vario again.
Thank you guys.
And I'm sure we will have more questions and more time to socialize. Our kind guests of Barter actually want us to be in the cafe, so they can set up this room for another event for tomorrow.
Yeah.
So you can take it to the cafe and